What's up, warriors? Hope you all are well. The purpose of this video is to talk and recreate the discussion we had on Solver from our logistics management class the other day. As fate would have it, or Murphy would have it, the video did not work for us on that day, so a lot of valuable instruction we lost. But the good thing is that we can recreate that right here, and that's what we're going to do here today. So I'm going to get my background noise turned down a little bit. So first, we're going to have 3 videos. This video will talk about optimization and Solver in general. The next video, video number 2, we'll talk about identifying the components and the network before we go into Excel and Solver. And then the third video will be inside Excel. We'll build our network, and then finally we'll wake up Solver and have Solver do what we need to do. Okay, so we're going to take this kind of gentle going in. First, we're going to talk about the whole point of all this in this video, which is optimization. And optimization is a modeling technique that we use for the purpose of finding one of 2 things. We want to see what the best performance is, and we do that by we define it and identify it in one of 2 ways. Sometimes both, but in Solver we only do it one of 2 ways. We either do it by defining a maximum. Okay, so this might be the max of cargo that we could move through a route, but most often the max profit we could achieve by using a certain logistics network, or a minimum. And here, our leading thing that we seek to minimize is most often cost. We might also seek to minimize volume if we do have some constraints, other things like that. But really, out of the times that we do optimization, in the top 3 times, the reason we do it is either to max profit or to minimize cost. And in our example today, we're going to minimize cost. Okay, super. So to do this within Solver, and again, Solver is not the only optimization engine out there, but it is a very popular one. First things first is we're going to have to identify what's called an objective function. And the objective function does just that. It either maxes or minimizes whatever we're trying to do. If we're trying to minimize cost, then that would be our objective function. And we would define exactly what that means. And that's exactly what we're going to do today. Another thing that we need variables. And we actually call these decision variables. Okay, so we need to define our objective function. We also need to define our decision variables. And these are the things that we want to decide how much we're going to do where, or at least have Solver decide that for us. In our example today, that's going to be how many units we move along a particular route, or we're going to call them channels today. So we have decision variables. Next, we're going to have coefficients. And coefficients go with decision variables, meaning that we multiply the coefficients by the decision variables. And we do that to determine the objective function. So, for example, if we decide we have Route 1 and we want to move 500 units along Route 1, that 500 would be one of our decision variables. Let's suppose that it costs $2 for every unit we move across Route 1. So that 2 would be a coefficient. And so we would take that 2 times the 500 and have a cost of 1,000, along with all of our other costs that would go into our objective function. Next, we're going to have constraints. And that constraints are arguably the most essential part of our optimization problem or within Solver. So Solver otherwise would go unconstrained, but we have to constrain it, number one, because of reality, and number two, so that really forces it to find the optimal point. Now, we have three types of constraints in the problem that we're going to do today. This isn't always the case, so don't lock yourself into this line of thinking. But we do have in our problem today, we have what's called supply constraints. We could also call these capacity constraints sometimes. We also have demand constraints. And then, and those are more unique to our problem today. They aren't by any means always required within Solver, these types of constraints. But very often we have what's called a non-negativity constraint. And that just means be positive, man. No, that's not what that means. Although it is good to be positive. Non-negativity means things like if we're moving units, we can't let Solver say that we're going to move negative 500 units because in this universe, that really isn't a thing. So we have to tell Solver not to do that. So supply, capacity, demand, and non-negativity constraints. And of course, once we're done with all this, we're going to go back and make sure that we've defined the objective function within Solver. So that's it for this video. What we want to do going into the next video is we want to remember this essentially is our scavenger hunt list. So we're going to define the network. We're going to define the objective function. We're going to identify our variables. We're going to identify our coefficients. And then finally identify our constraints. And we're going to do all those things in the next video before we go into Solver, which will happen in our third video. So thanks, and we'll see you soon. Stick around. Make sure you catch the next video.